Okay, so we just looked at a problem about an outdoor amphitheater, and it told us the first row has 32 seats, the second row has 34 seats, the third row has 36 seats, etc. And they're telling us there's 33 rows altogether in this amphitheater, and they want to know how many seats there are altogether. Well, here's the deal. I could literally write out all 33 rows with the number of seats in them and add them up. Or I can figure out if this is any type of sequence. And the types of sequences that we know so far are arithmetic and geometric. So think about it. If the first row has 32 seats, and the second row has 34, and the third row has 36, what type of sequence do you think it is? Yeah, this is an arithmetic sequence. So, I'm trying to find the sum of the first 33 rows, right? So, the arithmetic sequence formula looks like this then, doesn't it? Okay, so since you said it's arithmetic, what's a sub 1? 32. What's your common difference? Yeah, it's a positive 2 because each row goes up by 2, right? But I also need to know a sub 33, don't I? Wait a minute, what's n? Yeah, n is 33. But I also need to know the 33rd row, right? I need to know how many seats are in that 33rd row in order to work out this sum formula. Okay, so to find the 33rd, how many seats are in the 33rd row, how do I do it again? Yes, you take a sub 1, add it to, good, 32 times d. Well, a sub 1, you told me was 32. And I'm going to do 32 times d, which is 2, right? So what is that, 64? 96 seats in that 33rd row? Do you agree? Okay, so now am I able to find the sum? I certainly am. So the sum of those 33 rows is equal to n, which is 33, times the quantity, 32 plus 96, and the whole thing divided by 2. So I know your calculators are out. What'd you get? Good, I think we got the same answer. 2,112 seats. Yes? Okay, hang in there. I'll be Okay, so let's look at the next story. The next story was talking about somebody who had a starting salary of $55,000, and it increased every year by $2,000. And then they said they wanted to know how many years it would take for the aggregate salary to be $496,000. You're like, what do they mean by aggregate salary? Well, think of it this way. After how many years, what will the sum be? Okay, after how many years, when will your sum of all those salaries for all those years equal 496,000? With me? Okay, so here's the deal. If we're talking about a sum, then clearly I need to think of sequences and series, right? But the question is, which type of sequence do I have so I know what summing formula to use? Now remember, they start with 55,000 and every year it increases by 2,000. So if it's increasing by 2,000, what operation are they using? Yeah, they're using addition. So this is clearly an arithmetic sequence, right? Okay, so since it's an arithmetic sequence, that means I know that the sum of this arithmetic sequence looks like this formula. Agreed? All right, now let's start putting the pieces of our puzzle in, shall we? I actually know the sum in this case, don't I? Yeah, my sum is 496,000. Do I know n? Remember, they're asking for the number of years. Do I know the n? No, I don't. Do I know the first year's salary, a sub 1? Yes, that's 55,000. Do I know the a sub n? Nope, I don't. because I don't know the salary in that nth year. And all I know is it's divided by 2, isn't it? So here's the deal. I've got an interesting problem on my hands. A sub n, if I need something written here because this looks funny to have the A sub n notation. So here's what I need you to think about. A sub n is equal to the first term plus n minus 1 times d, correct? That's the generic term, right? Okay. A sub n then is equal to 55,000 because that's your first year's salary, plus n minus 1 times 2,000, right? Okay, let's simplify this a little bit. So I have 55,000 plus 2,000 n minus 2,000. Agreed? This is equal to a sub n. And finally, a sub n is equal to, that looks like 53,000 plus 2,000 n. Yes? Which means I can rewrite this problem as 496,000 is equal to n times, in the parentheses, or the quantity of 55,000 plus 53,000 plus 2,000 n. Are you with me? Okay, so, and again, that whole thing is divided by 2. So at this point, we got a lot of algebra to work with, right? We got to clean this thing up as much as possible, simplify it as much as possible, and see where we end up. Good? Okay, so follow along. Let's see if you agree with me. I am going to clean up that parenthesis a little bit. So I have 55,000 plus 53,000. What do you get? Yeah, you get 108,000 plus 2,000 n, right? All over 2. I'm going to distribute that n into the parentheses. So let's see, we get 108,000 n plus 2,000 n squared all over 2, right? Gratefully, both these numbers are even, so they'll divide by 2, won't they? So I end up with 496,000 equals, what's 108,000 divided by 2? Good. 54,000 n plus 1,000 n squared. Okay, and you're like, now what? Hang in there. I need some board space. I'll be right back. So I got myself some board space. So here's where we left off. And you're like, well, now what do I do? So here's the thing. In this particular equation, there's a trigger. There's a key that tells me how I'm to proceed from here. And that key is right here with the n squared. As soon as I see a variable squared, that means you're going to have to factor or use the quadratic formula, whichever you prefer, doesn't make a difference. So, regardless of which one you're going to do, you have to make sure this equation is set equal to what? Yeah, you have to make sure it's equal to 0. So, I have to move over that 496,000, and as I do that, I'm going to put this in descending order, because that's going to make life a little bit nicer for us, right? And remember what we try to do before we factor is we try to reduce, right? Try to make these numbers smaller. So I'm going to divide this entire equation on both sides by 1,000, because that's going to make our lives a whole lot easier. So gratefully, 0 divided by 1,000 is what? Yeah, 0. So that didn't affect the 0. But all these guys divided by 1,000 gave us, oh, much nicer numbers to deal with. With me? Now I factored it. You guys can use the quadratic formula, pause the tape, see about factoring it before you see mine. Okay, this is what I got when I factored it. Did we agree? Or if you use the quadratic formula? Okay, so that means each parenthesis gets set to 0 and solved. So I get n equals a negative 62, or I get n equals 8. So remember what n represented. Yeah, n represented the number of years that it was going to take for them to earn $496,000. Is it going to take negative 62 years? Nope. It's going to take 8 years, starting at $55,000 for the first year, going up $2,000 every year thereafter, and after 8 years, they would have earned a grand total of $496,000. Cool? Okay, hang in there. One more. So let's take a look at this last problem. They're telling us that you just got hired somewhere and you're starting with an annual salary of $16,000. Yeah, I know. Hang in there. You're like, that's not a whole lot. I get it. But regardless, annual salary starting at $16,000. There is an increase per year of 5%. And they want to know what's your salary in the fourth year. Well, here's the deal. The increase is 5% per year. So, answer me this. What operation are you going to use to find your salary from one year to the next? Are you going to add 5%? You're like, yeah, but okay, but how do you come up with the 5%? Yeah, you got to multiply to come up with the 5%, don't you? So, again, what kind of sequence is this going to be if you're going to multiply to come up with that actual dollar amount? Yeah, this is actually a geometric sequence. Yes, your first year, your first term will be the 16,000. And your common ratio, I'll be back to that in a second. And the number of years that you're looking for is 4 years, right? Now, I'm going to back up. You're not looking for the sum, remember. You're just looking for the salary in the fourth year, okay? Okay, so we'll get back to the common ratio. 5%. How do you write 5%? Yeah, 0.05. We never use it with the percent sign. So you're like, my common ratio is 5%. Yes and no. Because I'm trying to figure out the salary. I'm not trying to figure out the increase only. I'm trying to figure out the salary. So 5% is only part of the common ratio. The common ratio is your 5% increase plus 1. You're like, what's that 1 represent? This 1 actually represents the base salary. It represents the base salary. If I just take $16,000 and multiply by the 5%, that gives me the increase only, doesn't it? But if I take this and add the 16,000, the base salary to it, that gives me that total salary for that year, doesn't it? Right? So I have to add the base salary. The base salary is my whole amount. My 5% increase plus the whole amount of 1. Okay? So, and you're like, I still don't get it. Okay, hold on. Because some of you are still questioning the 16,000. So if you took 16,000 times the 0.05 and added 16,000, that would give you your total salary, right? Can't I factor out the 16,000? That would leave me 0.05 plus 1. There's your 1. Good? Okay, so my R is actually 1.05. Good? Okay, now that we're all on the same page and you understand why we have the 1. So here's the deal. Am I looking for the sum or just the 4th year? Just the 4th year. So I'm looking for a sub 4. So to find it, you're going to take a sub 1 and multiply it by the r to the power of 4 minus 1, because it's got to be the 3rd, right? To the power of 3, because r is 1 behind. All right, so you go with your calculators. I know you guys are punching this all in, and after I punched it all in, my 4th year, or their 4th year salary, whoever that is, the 4th year salary for this person was $18,522. Cool? Okay, you have fun with this stuff, and I'll catch you on the flip side.